Okay, then here's problem number 10. Eliminate the parameter and rewrite as a function of one of the remaining variables. That means y is a function of x, or x is a function of y. Then sketch and label at least 3 points with their coordinates as well as their t-values. This revolves around the fact of understanding that when you square this e to the t, you're going to get e to the 2t. That's all it means. So you could, for example, replace this with a different parameter. You could say e to the t equals s, and then this would look like s minus 1 and y is equal to s squared. Maybe it's easier for you to visualize that. And then we can add 1 to both sides over here, and then s squared is going to look like something like that, and then that is equal to y. So we get y equals x squared plus 2x plus 1. So by one mechanism or another, you're going to end up with this equation. Okay, so how are you going to plot that? Well, it's a double root. It's x plus 1, so the root is at -1, and it intersects the axis there. So this is what this function looks like. Y equals the square of x plus 1. But that is not what your original function said you could do. In fact, you're tracing out a lot more than you're allowed to. And that's why it says label at least 3 points. I mean, this is part of the reason why. It says label at least 3 points with their coordinates as well as their t-values. So I'm trying to give you a big hint here that the whole curve is not valid. So at t equals 0, we're going to have x is e to the 0 is 1, so minus 1 is 0. And e to the 0 is 1. So at t equals 0, you have x is 0, y is 1. So this is t equals 0. Huh, that's interesting. Well, what about t is equal to 1, or t is equal to e, or t is equal to natural log of 2? You could pick things like that. I'm going to just go ahead and pick t as 1. What's x? X is going to be e minus 1, and y is going to be e squared. So e is about 2.7, so we're talking like x is about 1.7, and y is about 8. So it's something like here. So that would be maybe t is equal to 1. Huh, that's interesting. So we know the curve is going like that. Great. So let's try going backwards. T is equal to -1. Then x is going to be 1 over e minus 1, and y is going to be 1 over e squared. Okay, so y is going to get smaller, and x is going to get negative. So x is kind of like 1/3 minus 1, so it's moving its way backwards, and so it's going to be somewhere like over here. Huh. Well, what about, t is equal to minus infinity? I'm just curious. At this point, I'm just curious what's going to happen. And so I'm going to get, actually, x is going to be 1, because I'm going to get 1 over e to the infinity, right? Because t is negative infinity, so you're going to end up with that in the denominator. And then y is going to be 1 over infinity, so that's 0. And then you say, aha, that is very curious, because that ends up being t is equal to minus infinity, and then as we're going plus infinity, we're getting the rest of the curve. But what it means is this whole part of the curve doesn't exist. This whole piece is gone, so we don't want you, we don't like you anymore, you don't really exist, okay? So this little thing was just a pretend piece of the curve. Sorry, but it wasn't really there. Okay, hope you had fun. Where are we?